After that I have my volume of surface area of a solid cylinder of a radius r. So r, it is called as a radius, and that is given to me, it is called as a 2 centimeter. So first of all I want my answer in the terms of a millimeter, so that would be 20 millimeters, and my height, it is a small h, that is again in the terms of a centimeter. So I am just putting 100 millimeter. You are aware that whenever we are going to the larger to smaller units, our power is incremented. So centimeter is containing 10 to the power minus 2 meters, and millimeter contains 10 to the power minus 3. So I am just going from the centimeter is higher compared to the millimeter part. My area of cylinder is 2 pi r multiplied by r plus h. So that is called as a symbol of A, that is a 222 by 7. For better calculation I have just placed that 22 by 7. My radius r, that is called as 20. Again my radius is 20 and height would be 100. So I can have an area that is called as a 44 by 7 multiplied by 20. You can say 880, and I have a 120. So my area would be, I have a calculator available to me, you can just also calculate by such type of data. My area would be 150.85 millimeters square. So you can calculate such type of calculations. So these are the very simplest simple type of examples. Third type of example they have asked in the subcategory. I have just given that a vehicle is moving with the speed of 18 km per hour and covers some distance, and the time has been given to me, that is called as a 1 second. So what they want is that what distance I have covered. So first of all you are aware about the expression of a speed, it is called as s, and that is given to me in the terms of a kilometer per hour, and the time they have mentioned in terms of a second. So first of all I have to convert this one in the terms of a meter per second. So always have a habit, directly you can just say that 5 divided by 18, that will convert your kilometer into meter and hour into second. So you can have your speed s equals to 5 meter per second, or initial level you can say that it is kilometer, so you can say that 1000 meters, and second from hour to second, that would be 3600 seconds. So 00 cancel out and 5 and 18, so it will be the same. So always have your habit to convert your kilometer per hour in the terms of a meter per second, and that will make your task very much easier. So I want to find it out my distance. So my equation of speed, distance upon time, I want to find it out my distance equals to speed into time. My speed I have found it out, it is called as a 5 meter per second, and my time is called as a 1 second. So I got that my distance is equals to 5 meter. If you remember, so in the clip of finding out the dimensional configurations and units, I have told you that okay, you can just also convert such type of thing and you can find it out unknown thing. Let's say you are not aware about that unit of a distance, so you can say second cancel out, the meter is left with you. So such type of mathematical calculations are also there available to you whenever you are calculating such type of data. Now I have been given that another good example, and that is called as my relative density of a lead is 11.3, and it's a density I have to find it out in terms of a gram and kilogram. So this is a new data for you. So first of all I am just mentioning all those configurations which is given to me, that is called as a density, it is called as a relative density. So I'm mentioning that relative density as a symbol of a rho. Density symbol is rho, and it is called as a relative, that is why rho r. Now they have just asked me that density of lead, I'm mentioning that rho of L, and I'm always comparing such type of density with the density of water. So I'm mentioning that density of water is equals to rho of W. So this contains relative always compares with another one. So it is called as a ratio of whichever metal given to you with compared to the water. Always remember, it is called as a density of water is 1 gram per centimeter cube. This is the ideal value you have to remember. Now what I am doing is that taking all those data, I want to find it out the density of a lead. So that would be a cross multiplication. So I can have a rho of L is equals to relative density multiplied by density of water. In my example, they have mentioned me relative density is 11.3, and that is in the terms of, I have to find it out my answer in terms of gram and kilogram as well. So I am using it. So relative would be 11.3, and this is called as a 1. Relative does not contain any type of unit, because if you place that relative density means it is containing either unit kilogram per meter cube or kilogram per meter cube, both will be cancelled out. So relative does not contain any unit. That is why I haven't mentioned any unit over here. But relative means density of water is given, that is called as 1 gram per centimeter cube. So I got that relative density of lead is 11.3 gram per centimeter cube. Now I want my answer in terms of kilogram per meter cube, because they have also asked me that kilogram per meter cube. So you can see that this is the kilogram per meter cube they have asked me. So from the smaller to larger unit I have to go. So to convert to kilogram per meter cube, meter cube. So I'm just doing that. 11.3 gram can be converted to 10 to the power minus 3. Centimeter is converted to meter, 10 to the power minus 2, and it's a cube. So I can have a 11.3 10 to the power minus 3 multiplied by 10 to the power minus 6. Minus 6 is going in the numerator. So I can have a 11.3 10 to the power minus 6 is plus 6 now, plus 6 minus 3. So that is why I have 11 10 to the power 3. If you want one more power, so first of all I am mentioning my unit. So this is actually my answer in the terms of a kilogram per meter cube. Or you can say that 1.13 cross 10 to the power 4 kilogram per meter cube. So this is another method. Whenever you have a power, you can convert such type of power by giving your power to the your 10 power. So I have just mentioned that my fractional point, decimal point given to the later part. So both method are useful. Sometimes your answer will be given in terms of like this one. So learn how to just raise your power. So if you want that 11.3 10 to the power 3, if you want that 113, then power will be 10 to the power 2. So such type of conversions are there. So remember such type of conversions. So this is your exercise example number 2.1. Now next will be 2.2. In the 2.2 they have asked us something new thing for us, and that is actually not a new thing. Some of the data which we have already learnt. So very first thing is that first of all they want 1 kilogram meter square per second square, and that would be converted into the term of a gram centimeter square second square. So this is the, let's say, x number, that would be gram centimeter square second square. Whenever such type of data you given to you, you can assume x over here and convert, or you can just say that directly you are aware that I am putting the same value. I want to go from kilogram to the gram. I want to go to the kilogram to gram, then meter to centimeter. So what I am doing is that I am going from higher to the lower unit. Kilogram contains 10 to the power 3 grams. Meter contains 10 to the power 2 centimeter, and it's a square. And there is no need for the second part. So you can just say that 1 10 to the power 3, but I am just already mentioning that second square because they are mentioned. So I can have a 10 to the power 3 gram, 10 to the power 4 centimeter square divided by second square. So you can have a 10 to the power 7 gram centimeter square second square. That is the value of 1 kilogram meter square per second square. In future you will also learn that. Remember, that is called as a unit of a joule. It is actually a unit of a joule. 1 joule equals to 10 to the power 7, that is called as a erg. This is mks, unit of energy, and this one would be cgs, unit of energy. So whenever in the future you will ask about such type of examples or values, remember that. So I am mentioning that mentos khao, दिमाग की बत्ती jalao. So this is the actually kilogram meter square per second square is basically, if you can check it out, our clip containing unit and dimensional configuration, you can find it out such type of data, which is also mentioning that what type of thing you have. So this is how you can calculate it out. So this is a joule, this is erg, this is higher unit, this is smaller unit, that is why power is a plus. Later what we will also learn that from lower to the higher part, you can say that vice versa. So 1 erg equals to how many joules? So you can say that 10 to the power minus 7. So this is the one type of a cross conversion. Now we want to convert that another part, that is called as a meter equals to light year. First of all, it is a very first conversion that people are always misinterpret this thing. Light year is one unit of actually a distance, not the velocity. So whenever they are asking such type of thing, always careful. Second one, 1 meter equals to how many light years? Basically light years you are aware about. Light year is called as a 9.46 cross 10 to the power 15 meters. This is how we have just learned that. It is mentioned as a ly. So I want that my answer in terms of ly. So I have to convert this in terms of a meter. 1 meter equals to how many light years? So what I am doing is that 1 meter equals to 1 divided by 9.46 10 to the power 15 meters. Basically this is called as a my distance covered by the light, velocity of light. If you remember such type of formula, we have this value, distance ct. This is called as a 3 cross 10 to the power 8 meter per second, and this is the time. I have just mentioned that 365.25 days, 24 hours and 3600 seconds. That is how we have just found it out. So 1 meter is equals to, I have is this much of a light year. So 10 to the power 15 is going in the numerator, and 1 upon 9.46, I can have a 1.057, and I am just increasing one power. So this is the distance covered in the terms of a light year. So this is actually a distance. Third one is given to me, that is called as I have 3 meter per second square, and I want to convert in the terms of a kilometer per hour square. So you are aware that I am converting my smaller to the larger unit. So meter is converted to 10 to the power minus 3 kilometers, and second is there. Second to the conversion is called as a hour. So 1 upon 3600. Second is now converted into the terms of hour. So I can just say that 1 upon 3600, and that is how it is called as a hour square. So I can have 3 10 to the power, and again it's a square. So I am putting a square over here. That is 1 upon, this is the conversion. So 1 upon 3600 square, it is called as a hour square, because they have mentioned second square. So I'm mentioning that second to hour is called as a 1 upon 3600 hours. So this is square, that is why I'm putting square. Multiply by 3600 square, kilometer square, divided by hour square. So I can have a, this is the value of a 3, this is the value of kilometer, and that is called as a kilometer only, and this is hour square. So I can have a value that is called as 3 meter per second square. This is how entirely will calculated, will give me that value over here, 3600 multiply by again 3600, then multiply by 3. This will give me 3.888. So I'm just converting 3.888 cross 10 to the power 4 kilometer per hour square. You can see on the screen that there are 3 and 3, 6 and something will be there. So that is called as a 3600, and 10 to the power minus 3 power is also there. So this is how it has been converted. Now next one, it is given me the value of capital G. Capital G is 6.67, 10 to the power minus 11 Newton meter square, kilograms square, and I want that in terms of such type of data. So first of all, I am doing that, all those things putting over here. So my data is that 1 means capital G is called as a gravitational constant. Its value has been given to me, and that is 6.67, 10 to the power minus 11, and that is called as a Newton meter square divided by kilogram square. I have to convert this value and find it out centimeters cube divided by second square, and that is called as a gram. Both are in a numerator, that is why they have mentioned that 10 to the power minus 2. If you see that this is the data, this is the data they have mentioned to me. So I'm just using such type of data. I am just putting those two in the denominator, that is why my power has been converted to the negative to positive, because I have just taken it and placed into the denominator. So first of all, what I am doing is that putting that 1 Newton. Newton is a unit of a kilogram meter per second square. It is the unit of a force. It is mentioned in terms of a name of the scientist. So that is why always remember that it is a 1 Newton. It is called as a kilogram meter per second square. So first of all, instead of a Newton, I am putting all those things. So I have a 6.67, 10 to the power minus 11. Newton is called as a kilogram meter per second square into the meter square and kilograms square. So first of all, I am just cancelling all those extra part. So my unit now I have 6.67, 10 to the power minus 11 meter cube divided by 1 kilogram left, second square left. Now you can see that there is a resemblance of a centimeters cube. Now it is called as a meter cube. Second square, kilogram, gram. So always have a habit, whenever such type of extra units, it is called as a derived units. You are aware about fundamental and derived units. Such type of derived units are there. Always convert to our standard MKS or CGS conversion. Now it is quite easy for you to convert all those things. So now I am just putting all those things over here. Likewise, I have already just written, so I am just mentioning over here again. So I can have a 6.67, 10 to the power minus 11, that is meter cube, kilogram, second square. I want to convert such type of unit from the higher to the lower unit, because as per my standard, what they have asked me is that this is the higher unit, from the higher to the smaller unit they want. So these are the smaller units they want. So I'm just converting. First of all, values will be as it is. Meter can be having centimeter. Centimeter is 10 to the power 2 and it's a cube. So I'm mentioning centimeter cube directly. Kilogram to I want to convert in the terms of a gram. So I have a 10 to the power 3. There is no power. So mentioning gram over here. Second square having no importance because second is second. In either you will take MKS or CGS. It will be as it is. So I'm putting that as it is. So I can have 6.67 10 to the power minus 11 10 to the power 6, and I can have a centimeter cube, and that is called as a 10 to the power 3 gram second square. So I can have a 6.67 10 to the power minus 11 10 to the power minus 3 and 10 to the power 6 centimeter cube gram second square. As you can see that your power in the numerator was negative. Now I have just converted that power in the terms of your 10 to the power minus 11 minus 3, that is called as a 10 to the power 6. So I can have a capital G is equals to 6.67 10 to the power minus 14 and 10 to the power 6, that is called as a centimeter cube gram per second square. That is why you can have a 6.67, base is same, so I can have a 10 to the power minus 8 centimeter cube gram second square. And as I have told you that you can also remember such type of conversion because Newton is also part of MKS and I want to convert, so always remember there is also direct conversion. So I am putting that one Mentos for you. 1 Newton is a 10 to the power 5 dyne, or you can say Newton is something MKS, that is called as a kilogram meter per second square. Directly conversion will give me that gram centimeter per second square. So as I have told you for the joule, 1 dyne is equals to 10 to the power minus 5 newtons. So these are the two wide units, widely and moreover used whenever you are just using such type of conversions. So these are the all examples mentioned in a single example coming under the single roof. So just solve it out and convert such type of examples. Moving to the extra another examples, that is called as example number 2.3 in front of us. In the 2.3, that is a very simple example, but for that you require some of the conversion concept. First of all, we are reading this concept. A calorie is a unit of a heat energy and it is equal to the 4.2 joules. Basically, calorie is another unit of energy. 1 joule equals to, that is called as a 1 kilogram meter square per second square. So first of all, I am just using that notation. E is denoted as a symbol of energy. It is called as a joule and it's called as a 1 kilogram meter per second square. I am just giving that equation number 1. You can also use that word E1 or E, basic units. Next one is that for the kilogram meter per second square or 1 kilogram meter per second square is having dimensional configuration M1, L2, T minus 2. Now what they have asked us is that we are just converting and employing another system where another mass is alpha kilogram. So this one for the first one, so I am mentioning that for the first one. In the another unit of a mass is called as alpha time of kilogram. For the kilogram I am using that alpha time of M1. Length is called as a beta time of meters. So beta time of meters. So beta length has been denoted meter. That is why I am just putting that L1, previous one. and my time t2 is called as the gamma times of second. I'm using that gamma time of t1. So my dimensional configuration of entire this E2 will be alpha time of M1, its power is 1, beta time of L2, its power is 2, and gamma time of T2, it's sorry, gamma time of power, that is called as a T1 raised to minus 2. I am taking the ratio 1 divided by 2. So I can have M1 L1 raised to 2 and T1 raised to minus 2. Same is the course, alpha M1 raised to 1, then beta square L2 raised to 2, sorry, L1 raised to 2. This is for the first one. And then gamma, that is raised to minus 2. Same is the course, T1 raised to minus 2. So what I have just mentioned is that cancel out of timing and all those things. So you can see that alpha is going in the numerator, that is why minus 1. Beta is going in the numerator, that is why minus 2. Gamma is minus already, that would be the plus 1. So these are the things you have. Or for another method I am just also mentioning for you. You can also try it out. You can just say that n1e1 is equals to n2e2. We want to find it out n2 for the second one. That is why you can say that n2 is equals to n1e1 divided by e2. This is the even part. This is the even part. It's having number 1. That is why 1. So you can place 1, m1, l1, l1 raised to 2 and t1 raised to minus 2. And these are all are the values of e2. You can place over here. So you can also get the same answer. So these are the very simple method in front of you. But this is how you have to learn. As on now, this is very initial methods, that is why quite you are not comfortable with. But gradually, by time passes, you will be habitual by such type of methods. Now you have been given that explain statement clearly and to compare the dimensionless quantity large or small is meaningless without specifying standard or comparison in the view of other. It means that you have been given some of the statements and you have to just say that these statements are either higher, lower, smaller, bigger, heavier or lighter with comparison to what, and you have to mention that. So always that is called as a frame of reference. It is called as a relative thing. Somehow you are in regular life facing that your percentages are lower, but you are always compared with someone else. That is why you can say your percentages is higher or lower, or maybe anything else. You are taller or shorter with compared to some other quantities. Same is the course over here. Whenever you have comparison, then and then you can say that it is higher or lower or heavier or lighter. Otherwise it has been clueless part. So we are just using those data. So first of all is in given to you is this part. We have been given that atoms are very small objects, but atoms are very much small. If we are comparing with the higher mass, let's say I'm taking 1 kilogram, then your atoms will be look like very much smaller part. That is why I have just placed a comparison. Jet plane moves with a great speed with compared to person walking. So I have to just compare this thing. The mass of Jupiter is very much large. You can say that I am taking another small planet, Uranus. With compared to Uranus, it is higher or larger one. The air inside this room is obtains a large number of molecules compared to, let's say I'm just putting a container, small container of a 1 millimeter by 1 meter by 1 meter size. So you can say that this air inside the room contains large number of molecules. Now we have been given a proton is much more massive compared to the electron. Yes, gradually you will learn its mass. Proton's mass is 10 to the 1.67 cross 10 to the power minus 27 kilogram, and mass of electron is a 9.1 cross 10 to the power 31. The mass of a proton is a 1.67 cross 10 to the power minus 27 kilogram, and mass of electron is a 9.1 cross 10 to the power minus 31 kilogram. This is the comparison they have mentioned. So in a previous four there is no comparison, that is why we were somehow clueless whether which one is a smaller or larger one. But here they have mentioned already such type of comparison, so this is already true. All are true, but we have to put from 1 to 4 we have to put some of the references, but right now in the fifth one there is no need to put any type of reference. The speed of a sound is much smaller compared to the speed of light. Yes, definitely. So these are the in the fifth one and sixth one they have mentioned such type of comparisons directly, so that is there is no need that we have to compare. So always some quantity is either larger or smaller is meaningless without we will put some reference. So these are the primitive ideas. Now we will have example number 2.5. In the 2.5 you have been given that a unit of a length is chosen such that speed of a light in a vacuum is a 1 unit. You are aware that it is called as a velocity of light in vacuum. Basically it is a 3 cross 10 to the power 8 meter per second, but they have mentioned that it is a unity. Whenever unit is there you have to place that 1. The distance between the sun and the earth we have to find it out, and the time it has taken is 8 minutes and 20 seconds. So first of all you are aware that your data contains minute and second. You have to convert this all those data in the terms of seconds only. So I am just taking 8 minutes multiplied by 60 seconds plus 20 seconds is already there. I have a 480 seconds plus 20 seconds, so my time would be 500 seconds. I want to find it out my distance, so my equation is called as a c is equals to d by t. I want to find it out my distance, it is called as a ct. As per data it is unity, so c's value is 1 meter per second and time is of 500 seconds. Second will be cancelled out, as I have told you that from such type of method you can also find it out data as well. This is the distance I have, it's called as a 500 meters. Now I have another thing that is called as example number 2.6. A 1 year calipers of 20 divisions, and we have to find it out, it's a scale. Next one is called as a screw gauge having pitch 1 millimeter and 100 divisions, and third one is called as an optical instrument. So we have to see that and find it out which instrument is very much accurate. So first of all I am just saying that a definition of accuracy is simple one. You can say that whichever instrument measures at a very low value is called accurate. This is the definition of accuracy. So first of all we have a vernier calipers. This is the example. There are 3 or 4 examples of a such type in your textbook. These are the practical type of approach examples. So first of all I am just giving you one Mentos moment. Always remember it is called as n minus 1 by n. It is called as our VSD. These are the new word for you, so I am putting that words for you. It is called as a VSD. It is called as a vernier screw or a scale division, and another is called as a MSD. It is not Mahendra Singh Dhoni. It is called as a mean scale division. In practicals you will learn such type of words. So first of all always compare for the vernier calipers. N minus 1, n means you have been given that 20 divisions. 20 minus 1 divided by 20. That is why you have a 19 VSD. Now you want to convert it. So that is a one conversion, that is called as a 1 minus 19 by 20. It is called as our MSD, mean scale division. That is called as a 20 minus 90 divided by 90. That is why 1 by 20. It is always in terms of a millimeter, because whenever you will use your vernier calipers, it is such type of facility. But you want to convert it this one in terms of a centimeter. So one power is incremented in the denominator. So that is called as a centimeter. So this is how our vernier calipers capability would be there. So I have calculator. I am just using 1 divided by 200 will give me 5 cross 10 to the power 3. So this is the power of it. So vernier calipers will capable enough to measure such type of area or such type of length, thickness. Now another one I want to find it out for another instrument, and this instrument is called as a screw gauge. So you can see that a screw gauge having the pitch. So whenever you are aware about such type of your screw, you are aware about such type of turns. So first one, second one, this distance is called as a pitch. To consecutive rolls. So such is the thing you will learn in practical. Right now it is useless to just discuss about such type of data. So screw gauge having, you have to just remember, that is called as a distance of a pitch, distance between the two consecutive patches, divided by number of division. It is the equation of it. So you can say that pitch is given to you is 1 millimeter and divisions are 100. So 1 millimeter divided by 100. I want to convert this one in terms of centimeter. So 1 divided by 1000 centimeter. So you can have now 10 to the power minus 3 centimeter is the capability of your screw gauge. You will learn about such type of instruments in the laboratory. Right now if I will just take you this one is a very depth part, you will be somehow feel boredom, because of without instrument I cannot justify such type of data, but this is the practical formula. Such type of questions are already been asked in your JEE and NEET exams, so always remember such type of formulas. So for the previous part we have discussed is that our vernier calipers number of divisions minus 1 upon n total, and then it is again subtracted from the 1, that will give you that its capacity to measure the data. Then you have a screw gauge, its formula is called as a pitch, is called as a number of 2 turns. You can just say that such type of a spiral you have. This is the first one and this is the second one. So this distance is called as a pitch divided by number of divisions. The such type of divisions are there. So you will learn about this instrument in lab as well. There are number of screw gauge which is having different capabilities. Now the third thing we have to find it out is called as an optical instrument that can measure light to within the wavelength of light. So first of all it is called as a wavelength of light. So I can just use that wavelength of light. It is basically 1 angstrom, and in the 10th you have learned that 1 angstrom is called as a 10 to the power minus 10 meters. So I can just say that 10 to the power minus 7 centimeters, because you are aware that meter to centimeter, 10 to the power minus 10 meter, centimeter means 10 to the power, again I will give you some of the powers. So 10 to the power minus 7 centimeter. I want to just convert in the terms of millimeter as well. So I can have a 10 to the power minus 5. So its capacity is higher compared to the previous two parts. So which instrument is having more and more or precise capability? So you can say that wavelength of light is having higher and higher capacity. So such is the power you have. So in the next clips we will discuss about more examples. Thank you.